Hello everyone, welcome back. Today I'm going to discuss about another important topic in Python. The previous videos we have seen how can we get the input from the keyboard and how can we print the output in the terminal. And before going to the next stage, I want to discuss one more topic that is called the file descriptor. It's called the file descriptor. File descriptor. Before going deeper into the technical thing, let me explain the things in a layman language. Suppose you are going to a restaurant. Okay, suppose you're going in a restaurant. There we have multiple teams are there. One is called, this is the counter number one. And I have one more counter that is called the counter number two. Counter number one and counter number two. And where we have the usage which is coming in. Okay. Usage will come in. Either they can give order, or if there is any issue, they have to report complaints. Complaints. Okay. This is the order counter. This is the complaints counter. Order counter and complaint counter. This is all about this restaurant. This is a restaurant. This is a restaurant. The users will come, either they will give the order or they will raise a complaint. Either way, we will get an output. Either way, we will get an output. The first output, we call it as normal output. Normal output. The second one, we can call it as something error, or maybe it's a warning. Maybe it's a warning. Suppose if the management want to record the order details, then they can count to this order counter and they can start recording order. Okay. Or if the management want to record the complaints, then they can come to the complaints counter and start recording the complaints. Okay. So here we have the input. Input from the usage. Input from the usage. Either it can be an order input or it can be complaint input. Or in other ways, we can say user is giving the input here. Okay. Either it can generate an order or it can generate a error. We can say like that. Here, maybe sometimes the management want to record both of them, both the normal output plus error or warning, or could they want to take the report of both of them. If you convert this analogy into a computer programming way, we have something called input. Okay, we have something called input. Okay, we used to get the input from the user. We have something called output. We have something called output, and we have something called error. We have something called error. In every computer, these three items are denoted with three different numbers. Input are denoted by number 0, okay? Output denoted by normal output denoted by 1, and error or warning. This is denoted by 2. These are called file descriptors. File descriptors. This is called FD0, FD0. This is called FD1, FD1. This is called the FD2. These are called the file descriptors. The computer can understand these numbers, okay? Understand the file descriptor numbers. Understand the file descriptor numbers and route this output to the appropriate files or locations. Again, route to the appropriate files or location. These are called file descriptors. Once again, we have this program. We have a computer program. We have a computer program available. From the computer program, we have two kind of output. One is stdout and another one is std. Yeah, we call it as like this file descriptor. Here we have seen this input Or in other ways, in the program, we will be giving some input. Okay, input. This is called std and std in. This is called this std in or standard input. We have the normal output. That is called the std out. Let's write it down in different color so that it will be clear. We have something called normal output. We have something called this normal output. Or we have error or warnings. Normal output or error warning. This normal output, what we call, and error output, what we call. The normal output we call it as std out. std out. Error or warning we call it as std error. We call it as std error. These are the three file descriptors available in any computer program. std in is fd0, fd0. Okay. std out, this is file descriptor 1, and std error, this is file descriptor 2. File descriptor 2. These are the file descriptors. This is what I just want to discuss with you. I just want to discuss one more thing. How we want to use this file descriptor in our program. Suppose while we are doing this programming and all, we don't do this print to terminal. We won't do like that always, right? Instead of that, we will route this output to either some output file or error file. Sometimes if you see the directories, program directories will be something called out.txt or output.txt or error.txt. Sometimes we will route both of them together to a single file. Okay, single file. At that time will be something called r output.txt. I'm just giving some name. What I want to say is either we can output separately or the output normal output will go to the output file and error and warning will go to the error test. Otherwise, if you want to capture them together, then we can combine both of this error and add this to a single output file. This is what how we are going to do. And we're going to see how to do them practically in any Python programming. Let's go ahead and see them in practical so that the concept will be more clear. Let's open the cursor. Here we are going to write some Python program, not a detailed one, a sample program. To do any output redirection, then we have to import sys module. Okay, import sys. Import sys because the input and output redirection or functionalities are residing this in the sys library. From there, I'm just printing import sys. Suppose if you want to print something, then we have to call sys dot std out dot write. Then what do you want to write? Hello world. Okay, hello world. Just save it and try to execute this one. Python script.py. Hello world. This is the same functionality we are using. Print hello world. Save it. If you execute this one, this is also the same thing. What is the difference? There is no difference. The print is a function which is wrapped around this std output dot write. Both are doing the same. As we are not going to take this is std out write. Instead of that, we are just calling the print functions. Internally, print will go and execute this one. Sys dot std out dot write, and it is executing the same. This is what internally it is happening. Whenever we do the printing, it will go to the std out and it will write. If we want, we can redirect this one to some other file. How can we redirect this to some other file? That is what we are going to see. Before going to see this one, before going to the next level, I just want to show you the difference between sys.std out and print. Suppose I'm going to use this one sys.std out to write once again, hello world. This is hello world. This is I'm just going to give my name and just save it. If we execute this one, sys.stdout.write hello world and sys.stdout.write, this is hello. We're going to execute this one. What we're going to get this is, sorry, I didn't meant to give this \n. I meant to see that. Okay, if we execute this one, let me clear the screen. Okay, sys.stdout.write. If we execute this one, it is going to give it in the same line. Stdout is going to give us how many lines are there. Okay, even though these many lines are there, it is going to execute in the same line. It is not going to the next line. Whereas I'm going to comment them out, and I'm just giving print hello world. Then again, I have put in this 10. Okay, if you execute this one, it is going in separate new lines. Why? Because this print is wrapped around the system.stdout.write, but at the same time, whenever we call the print function, the second print will go to the new line. Second print will go to the new line by default. If you want to do the same for, if you want to do, just comment out this one. And if you want to do the same for system.out.write, stdout.write, then everywhere you have to give escape character new line, that is \n. Then again, you have to give this \n. Again, you have to give this \n new line. Yeah. Then only it will go to this different lines. Otherwise, it is going to print it in the same line. stdout, sys.stdout.write is going to print it in the same line. This is the difference between stdout.write and print. Both are working and give the same output. Print is a wrap around this stdout.write. This is the difference. Now we are going to see another important topic is how can we redirect this output. We have the normal output is there and we have this error output is there. How to rewrite this output to the respective files. That is what we are going to see next. Okay, let's go ahead and create a new file. The thing is, I have the stdout. We have already seen how to do this stdout. It will be sys.stdout.write. It will go to this standard output. Now I am going to have a mix of things. I am going to have the error also. Then how can we redirect them? How can we do it? Import sys. Then I'm going to print the output. This is the I'm going to start the program. Then I'm going to write a warning. I'm going to write a warning. And warning should go to which file? Warning should always go to the file sys.error. It is not the sys.stdout. This is sys.stderr. It has to go. Then I'm going to have something called normal output as completed. Okay, completed. This completed. Save it. And you execute this one, Python script 1.py. Sorry, Python script 2. Script 2.py. Starting the program, warning, and completed. Let's clear the screen, execute once again. Here, starting the program. Okay, it has started the program. And we got the warning. Let's go to the warning, print, completed. Looks same, right? Even though it looks same, this is going through two different streams. This warning is going through stderr, and the remaining two are going through the normal output, that is stdout. Let's go ahead and take another example, or script 3.py. Script 3.py. Script 3. I'm going to say import sys. In machine learning and AI, artificial intelligence, we used to give this accuracy and all those things will be monitored and collected, right? So I'm going to say sys.stdout.write, not the hello world. I'm just going to say model accuracy. Model accuracy is 94%. Model accuracy is 94%. But at the same time, I have some GP warnings. How we are going to capture that? Sys dot, I'm going to say stderr dot write. You can say GPU memory is low. Okay, GPU memory is low. GPU memory is low. Save. And once you are going to execute this Python 3.py, model accuracy is 94% and GPU memory is low. Even though we are getting the both output in the terminal, internally it is going through two different pathways. How it is going through two different pathways? Let me explain it. We have the program start running. Let this program started running. One output we got. What is this? STD normal output. Normal output. It will go to this STD out. The second thing what we got is STD out. The first one we got this STD output, and the second one we got some GPU memory one GPU memory one, or we can call it as error, or this will go to stderr. These two messages are passing through two different file descriptors. This is fd1 and this is file descriptor 2. File descriptor 1 and file descriptor 2. But in the terminal, we get both output in the terminal. We got both output. We got both output in the terminal. This is how this program is working, and where it will get reflected. Once you start redirecting this output to file, redirect output to file. At that time, we can see this std out, we can redirect to output file, and std error we can output to error log file. This is how we can do this std out and std error. We are going to see that example also as a part of this. Let's erase this one. Let's go ahead and see another program. I'm going to write script 4.py, script 4.py. Here I'm going to write this program. Okay, what's this? Loading data, training model, accuracy 95%. At that stage, we have this GPU memory is low. If you want to redirect this error, then we have to specify this file descriptor, std error file descriptor, separately. For normal output, we don't need this. Just say this and execute this script 4.py. We got all of them together. Now, see the magic. I'm going to reroute this output to different files. Let's see how can we do that. Okay, suppose let's clear the screen, and I'm going to reroute Python script 4 dot no, script 4.py to redirect why all those things. Script 4.py. I'm going to route it to output.txt. I'm going to route this to output.txt. It has created a new file here. We can see output.txt. See the content. If you see the content, even though if you execute this one by the script 4.py, we have got all the things together. This is the output and this is the error we have logged. But whenever we start rerouting this output to a file, then we got only the normal output. We got only the normal, that is std out. Where does this error came, or where does error went? It is not going to route it here. We have to specifically say that to which location or which file we need to route this error. In that case, what we need to do? In that case, what we can do is Python script 4.py script 4.py. Now, what you want to redirect? If we are not specifying any file descriptor, by default it will go to the std out. If you want to redirect to the error, then you have to specify the file descriptor name. What is number? What is the file descriptor number for error? That is 2. We need to route this file descriptor, that is the error, to where? I have error.txt. Now what it is doing, it will execute this Python program. Wherever the error is there, that error will be routed to error.txt. We can see it has created error.txt file, GP memory low. Whereas this output is still the same. This is how we are redirecting this output and error to two different files. That is the beauty. Let's go ahead and see a few another example so that the concept will be more clear. Suppose I have some use case. My customer wants both of them has to be redirected to a single file so that they can analyze only one file. They don't want to do multiple file analysis. In that case, what we can do is we have to say Python script4.py. I need to redirect the error. I need to redirect the error to which file? I need to redirect the error, not only error, and I need to redirect the error and what else you want to and I need to redirect my stdout. What else we need to redirect? I need to redirect the error and stdout to which file that we need to specify. Before giving the file descriptor, I need to specify out.txt. I'm going to redirect to out.txt file. What are the things or what are the logs we are going to reroute there? That is, I need to reroute my error and I need to reroute my stdout. This is not the meaning of and. What it is saying, I need to reroute the error to the file where this stdout is pointing to. That is the meaning. It's not just and. So what is it meaning? Python, I'm going to execute this file. What are the error and what are the output we are getting? It has to be written into this file. Now, how to specify both of them has to be written in the same file, give the file descriptor. If you want to write both the file descriptor in a single file, then we need to specify this error where you need to write this error. If it is a just error, just we can just give previously error descriptor and file name. If we want to write both of them together, then we need to specify, I need to write the error into the file where the stdout is pointing to. That is the meaning of this file. This command, if you execute this one, both of them will be written to a single file. Both of them will be written to a single file. Now we have the stdout as well as the std error. This is how we are using this stdout and stderr, and this is how we are using this file descriptor to write any log files in these specific files. Okay, and this is all about this stderr and stdout and stdin, and we have discussed about the file descriptor and how to write the stderr or stdout into different files and how to redirect them to the appropriate files and all. Hope you enjoy this video. See you in the next one. Bye. Have a good day.